So today we're going to cover chapter 10, section 2. Today we're going to learn how to find arc measures. Now, before we actually start doing these calculations, we've got a lot more vocab to cover. So the first thing we're going to do is define what a central angle is. And a central angle is an angle whose vertex is the center of the circle. So in this picture, angle ABC here is a central angle. Now, you can also name it in reverse. So you could also name it CBA is also a central angle. The sides of this central angle are going to be radiuses or radii. Now, if I were to add in another point here, let's say I add point D here, I could also now name another central angle. I could use these two radii, and I could call that angle DBA. Again, notice the middle letter is that center point. Or you could go in reverse, ABD. You could also realize that you have this bigger central angle, and you could go from the D all the way to the C, so angle DBC. So the circle, depending on where you draw in your radii, there could be a bunch of central angles within the circle. We're going to need to understand what a central angle is in order to find an arc measure. So an arc is a broken part of a circle. We have minor arcs, which are going to be arcs that are less than half of the circle, and they're going to measure less than 180 degrees. Then we have semicircle arcs, which are half of the circle, which are going to measure exactly 180 degrees. And then you have your major arcs, which are going to be an arc that's greater than half of the circle, and it's going to measure something that's greater than 180 degrees. On the quiz, you're going to need to be able to find a missing arc measure and classify it as either minor, semicircle, or major. So in this picture, this is circle B. Remember, you name a circle based off its center point. So this is circle B. Remember, you either write the word or the letter. So in circle B, they're giving us that DC is the diameter. So this diameter is actually a straight angle. And its endpoints are the endpoints of the semicircle arc. However, let's first look at the first one, and it's naming arc AC. When we're talking about an arc, this is the broken part of the circle it's referring to. So it's this little curved piece of the circle. So this is arc AC and arc AC. So arc AC here is a minor arc. When you are given an arc name like this that's got two letters, we're looking for the smaller piece of the circle. Because technically, you could also say, well, what if I went this way? This would be a major arc. So generally, when you see two letters, you're going the smaller way because they're referring to a minor arc, which is less than half of the circle. Now, again, when we name an arc, you're either going to write the word arc, which is the letters ARC, or you can put the two capital letters and draw a picture of an arc on top. If all you do is list the letters AC, I'm going to think you're referring to a segment. So you need to include the appropriate symbol, just like we learned back in chapter 1 when we learned how to name things. So the minor arc can have 3 letters, but generally when you're given something with 2 letters, you're looking for a minor arc, which is less than half of the circle. Now arc DAC here, notice the endpoints are the endpoints of the diameter. So this is a semicircle arc. And again, you could name it with the 3 letters with the picture of the arc on top. Now, when you go to figure out where an arc is located, when they give you the 3 letters, you have to go in order. So for this one, I'm going to go start at the A, right here, and then I'm going to go to the D, and then around to the C. This is a major arc. It's more than half of the circle. So again, you could name it ADC and put the picture of the arc on top. So when they give you the 3 letters, you have to go in order. And sometimes it's clockwise, sometimes it's counterclockwise. It depends on where the letters are located. So to find the measure of an arc, and that's what the little M here in front of each of these represents, the measure of the arc. The measure of an arc is equal to the measure of the central angle. So this is why we had to define what a central angle was. So in this picture, they're giving me one of the central angles. Now, also what I'm going to give you is I'm going to tell you that DC, that segment, is the diameter of circle B. And again, you could just put the little circle and then the center point. So in order to find the measurements of these arcs now, so in order to find the measurement of arc AC, which is right here, I'm going to use the central angle. Remember, the central angle is formed by the 2 radii. So because this central angle is 50, then arc AC is also 50. So you'll be doing things like this on the quiz. In addition to finding the arc measure, you will also have to classify this arc. This arc is less than half of the circle, so this would be a minor arc. Now to find CAD, and again, I'm going to go in order. So C is here, then I go to A, then to the D. So for CAD, notice its endpoints are that diameter, and this is forming a semicircle arc. So this will measure 180 degrees, and it's a semicircle arc. And then the last one, they're asking me to find the measure of ACD, and again, I'm going to go in order. So I start at the A, I go to the C, then I go around to the D. Now, in order to find this measure, notice this is the diameter. So this part right here, from C to D, this is 180. So in order to get the whole thing, I'm going to add 180 plus 50, and that measurement is 230, which is more than half of the circle, making it a major arc. Now, let's say they asked us to also find arc DA or AD, this one. So let's say they said find the measurement of arc AD. Then here, since I know that this is a semicircle arc, the endpoints, to find AD, I can do 180 minus 50, and I get 130 degrees, which would be the measurement of arc AD, because this central angle is 130. Because together, this is a straight line, and that's 180 degrees. It's a straight angle. In the homework tonight, you're going to be doing simple calculations like this. I want to see this in your work, that you're adding 180 plus 50. I know you can do it mentally, and I know you're using a calculator, but I still want to see what you think you're putting in your calculator. So show me how you're getting to that measure of that arc. by showing me what you're doing in your calculator. Next, we're going to define adjacent arcs. And adjacent arcs are arcs that have exactly 1 point in common. They're actually arcs that are right next to each other. Now, prior to this, we had adjacent angles. And adjacent angles were two angles that were right next to each other or shared a side. Adjacent arcs have a point in common. Now, this figure here, this circle, has a bunch of different adjacent arcs. So an example for a pair of adjacent arcs could be TQ is adjacent to QR. So I could say TQ and QR are a pair of adjacent arcs. And again, remember to include the arc symbol on top. Notice the point in common is the point Q. Now, adjacent arcs cannot overlap. They just have to be sitting right next to each other. Another pair, there's multiple here, another pair of adjacent arcs could be TS is adjacent to SR. They're right next to each other, and they both have in common the letter S. So these are just some examples of adjacent arcs. Now, let me show an example that would not be adjacent arcs. So notice the red TS and the blue one straight across, the QR. These are not adjacent. They are not next to each other. And notice there is no point in common. So adjacent arcs need to have a point in common, and they need to be right next to each other. And again, remember the arc symbols on top of your capital letters. Next, we're going to talk about the arc addition postulate. Again, don't memorize the number. Now, we saw this before at the beginning of the school year with the angle addition postulate and the segment addition postulate. Now we have the arc addition postulate, and this states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if I wanted to find the measurement of arc ABC, and I go in order, all I would need to do is take the arc AB, that little arc, and add it to the other arc that it's adjacent to, BC, and that would give me the whole measure for arc ABC. Next slide is a theorem. Again, don't memorize the number. It's called the congruent circles theorem. And here it states that two circles are congruent circles if and only if they have the same radius length. So in this picture, I can state that circle A and circle B are congruent because they have congruent radius lengths. So they'll either give you congruency marks on your radiuses or your radii, or they could have also said this AC, maybe they'll say this radius equals 2, and then they would have had to have given you that this radius length is 2. So they may give you the radius length in numbers, or they might just add congruency marks or tell you that the radius lengths are congruent. Congruent arcs are two arcs that are congruent if and only if they have the same measure and they're arcs from either the same circle or from congruent circles. And we just saw congruent circles. They're two circles that have the same radius length. So I'm going to draw some circles here to demonstrate what I mean by same circle or of congruent circles. So if I draw a circle, And I'm going to go ahead and draw in a diameter. So I'm going to add my center point. Then I'm going to draw in 2 diameters. I'm going to add in some numbers and letters. So I have E, F, A, C. So in this picture, if I tell you that the radius length here is 3, and if I give you that the central angle here is 80, also what I can determine, since this angle is 80 on this side will also be 80, because these are vertical angles. So because I have 2 congruent central angles, then I also know that these arc measures, arc AC and EF, will also be 80. So because I have 2 arcs with the same measure within the same circle, I can state that arc AC is congruent to arc EF because they have the same measure and they're in the same circle. So in order to state this, they have to be the same circle and they need congruent arc measures. Now let's say we have a different circle. So let me draw another circle right next to it. And let's say I label this one also with a radius length of 3. And let's call this LM. And again, my figures are not drawn to scale. So in this picture, notice both circles have the same radius length. So I can state, and let me add a letter here, I'll call this circle B. So I could state here that circle B is congruent to circle X because they have the same radii length or congruent radius. So because both radiuses are 3, if I add in an 80-degree central angle, and if LM, because the central angle is 80, so is arc LM. So because these are congruent circles, I could also state that LM, arc, is congruent to AC, or I could also say LM is also congruent to EF. Because they're from congruent circles, so we have congruent circles and congruent arcs. So because they're from congruent circles and their arc measures are the same, I could state that those arc measures are congruent. Let me draw one more circle here. So let's say I draw in one last circle. And I tell you that this one has a radius length of 5, but a central angle of 80. We'll call this circle Y, and then B, and then N. So because I have a central angle of 80, this arc measure is also 80, but I cannot state that arc BN is congruent to LM because these are not congruent circles. Even though they have the same arc measure, because they're not from congruent circles, those arc measures are not congruent.
Because that's a different radius.
Correct. Because our radius lengths are different, these circles are not congruent, so these arc measures would not be congruent. All right, next, another theorem. It's called the congruent central angles theorem. And this one states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So in this picture, because I have congruent central angles here, then I also know that these arc measures are also going to be congruent. And this is when it's in the same circle. So if I told you that this angle is 40, then this angle, because it's vertical to it, is 40. And then the arc measures would also be 40. The next theorem is called the similar circles theorem. And basically all you need to know that all circles are always similar. Because if you remember back to your similar triangles chapter, this is where you had to use one of the shortcuts, angle, angle, side, or side, and show that the sides were proportional. Because the circles only have one length to compare, and that's the radii, all circles are always similar. So two arcs are similar arcs if and only if they have the same measure. So here it wants us to name all these parts. Now before we start that, this is called circle O. So you can put the little symbol and then the center point. And I'm also going to tell you that AC is the diameter. This is going to help us to determine where the semicircle arcs are. All right, so in this picture, it wants us to name two minor arcs. Remember, minor arcs are less than half of the circle. So I have a minor arc right here of AR. You could also name it RA. I also have another minor arc, which is half of the circle, and this is RC or CR. Those would both be minor arcs. For the major arc, we're going to name it with 3 letters. So remember, we need to pick a starting point and we need to go in order, and it needs to be more than half of the circle. So let's say I want to start at A, right here. So I could go around A to R to C. This is half of the circle. And then if I need to go more than half, I could stop at D. So a major arc could be ARD, or if you wanted to say it's ACD, or you could go in reverse as well. You could have also called this DCA or DRA. Either way. Now, you could also start at R. You don't have to necessarily start at A. Another major arc could be starting here at the R and then going R to C to the A. So another major arc could be RCA, or go in reverse and maybe do ADR. Again, you just go in the order of the letters. So it all depends on where you start. You could have also started at C. So there's multiple major arcs in this picture. Now, the semicircle arc, the endpoints of that semicircle arc are going to be the endpoints of the diameter. So remember, we were told that AC was the diameter. So here's my diameter. So I have a semicircle arc going from A to R to C. So A, R, C, or in reverse, C, R, A. If you would name this AC, you could actually name it with just 2 letters, or ADC. So let's just do ADC. We'll do it with 3, ADC. Or go in reverse, CDA. So that would be this half. And it wants me to name an acute central angle. Now I really don't have any numbers here, But the only one that looks like it's less than 90 would be this one. This one I can't really assume. So I would say the only one here is AOR, or in reverse, ROA. And the only congruent arcs I know for sure are going to be the 180, the semicircles. And I can name, I've already named those. So my two congruent arcs are going to be ARC and ADC. And again, you could go in reverse and call it CRA or CDA. But the only ones we know for sure, because we were given that AC was a diameter, is the only ones that we know for sure are congruent are those semicircle arcs. One last example. So the last one wants us to give the measure of each angle or arc. So again, this is called circle O. And you're going to be given that YT is the diameter. Now we're also given an arc measure and an angle measure here. So because O is the center, here's a central angle, XOY, and then this arc measure would be 30. Then I also have an arc measure here of WT. So then I could also show that this central angle here, WOT, is going to be 50. So this would be its corresponding arc. And then the corresponding arc for here is the 30. So now it wants me to find WX. Well, WX is over here. Now I was told that YT was the diameter. So I know that the diameter is going to form a semicircle arc. And I know a semicircle arc is 180. So in order to find XW, I'm going to add 30 plus 50 and subtract that sum from 180. And that'll give me WT. So WX, 180 minus 80, and it's 100 degrees. So this central angle is 100, and so is its corresponding arc measure. So WX is 100 degrees. The next one wants me to find the measure of angle WOT. Well, I already did that. It's this purple angle right here. And it's going to be 50 degrees. So sometimes when you start to fill in your picture, you already have the answers to some of the problems. Now, WX, let's go ahead and classify that. That's less than half of the circle. So this is going to be a minor arc. And WOT is just an acute angle. Now let's find XYT. So X goes, and we're going to go in order. So we start at X, then we're going to go to Y, and then around to the T. And notice it's more than half of the circle. So this is a major arc. And the way that I'm going to find that is if you recognize that right here is a semicircle arc. And if this piece is 180, all I have to do is the 180 plus that minor arc of 30, and arc XYT is going to be 210 degrees. So this will equal 210. This is more than half the circle, so this is a major arc. And then the last one wanted me to find the measure of YOT. And angle YOT, well, I just did this. This is the semicircle arc. So it's the straight angle. So angle YOT is 180 degrees. And that is it for the notes on 10.2.